Hi, welcome to our video on writing rational numbers as decimals. First thing that I'd like to review is what a rational number is. And our nice, easy definition of a rational number is any number that can be written as a fraction. When we change a fraction into a decimal, it's very simple. All we do is divide the numerator by the denominator. So in order to change a fraction to a decimal, divide the numerator by the denominator. And there's some really good vocabulary in here. If you remember from last year, we have the word numerator, and that's simply the number that's on the top of the fraction. And we also have denominator, and that's whatever number's on the bottom of the fraction. So we're going to do a couple examples. I'm going to start off with the fraction 3/5. And in order to change a fraction to a decimal, I'm going to divide the numerator by the denominator, which means I'm doing the problem 3 divided by 5. One of the most common errors that we make is putting the 3 and the 5 in the wrong location here. So one little trick that I like to think of is I like to imagine that this fraction bar here is actually a diving board. And over here, this is a pool. So the number that is on the top of the diving board is going to jump and land into the pool. And the number that's not on the diving board is going to stay outside the pool. And now that I have my numbers in the correct places, all I need to do is solve a long division problem. So since 5 can't go into 3, I'm automatically going to add a decimal point and a 0. And that decimal will come straight up into my answer so that I don't forget later on. 5 can go into 36 times, so 6 goes above the 0. I multiply 6 times 5, that gives me 30. And if I subtract 30 minus 30, that leaves me with 0. So 3/5 as a decimal is equal to 0 and 6/10. Sometimes we're going to work with a fraction that is actually a negative fraction, such as the fraction -2/3. Even though the fraction is negative, I'm going to follow the same process that I would with a positive fraction. I just have to be extra careful that at the end, I make sure that I put a negative sign on my answer. So I'm actually going to jot it down right now so that I can't forget later on. And I know that this has to be a division problem. Again, I'm going to imagine that this is a diving board and that I have a pool here. And so since the 2 is standing on that diving board, the 2 is going to go into the pool and the 3 is going to stay outside the pool. 3 does not fit into 2, so we're going to add a decimal and a 0. And again, before I start dividing, I'm going to bring that decimal point straight up into the answer. 3 fits into 26 times. 6 times 3 is 18. I'll subtract 20 minus 18. That gives me 2. So I'll add another 0 and bring it down. 3 goes into 26 times. And you're going to notice that a pattern appears here. I'll take it one more round just to make sure. 6 times 3 is 18. 20 minus 18 is 2. So when we get a fraction like this, where I have a digit or more than one digit that constantly repeats itself, we call this a repeating decimal. And so what I'll do is I'll use what's called bar notation to show that it is a repeating decimal. So that means I'll just take my pen or pencil and I'll put a line over the digit or digits that repeat. So -2/3, I already brought my negative sign over here, is equal to 0.6 with a bar notation, so it's 0.6 repeating. One last example here. We can also take a mixed number and make that into a decimal. And what happens with a mixed number is that you're still going to have that whole number. So when I'm done, my answer is going to be 1 point something. And I'm going to figure out what that something is the same exact way we did it in the other two problems. So again, the fraction bar is a diving board. The 4 dives in, falls in the pool. 5 stays outside. 5 cannot fit into 4, so I'm going to add a decimal and a 0. Bring that decimal straight up into my answer. 5 can fit into 48 times. 8 times 5 gives me 40. And if I subtract here, I will get 0. So 1 4/5 is equivalent to 1 8/10, or 1.8. A decimal, like what we see here in 1.8, or what we saw in our first example, 0 6/10, is classified as what we call a terminating decimal. I hope that you found this video helpful. If you have any questions, please jot them down and bring them to class tomorrow.